Hi there. The topic of today's video is the formal definition of a limit. Now recall, the formal definition of a limit we are looking at for a general epsilon greater than 0. We want to find a delta greater than 0 so that 0 less than the absolute value of x minus a is less than delta, given that the absolute value of f of x minus L is less than epsilon. So we want to make sure that we keep track of this absolute value of f of x minus L is less than epsilon, and this idea of 0 is less than the absolute value of x minus a is less than delta. Now I want to just make a comment with the yellow highlighted part that 0 is less than part just actually tells us that x cannot equal a for that part of the inequality. Now for our example of this process, we're looking at for epsilon greater than 0, find a delta greater than 0 necessary to prove that the limit as x approaches -4 of 8x plus 30 is equal to -2. Now we are going to go through the same steps that we did when we had that intuitive approach and we had a specific numerical value for epsilon. But instead of having a specific numerical value for epsilon, we're just going to bring the notation for epsilon along the way. So remember, we start with what's highlighted in blue, and we also want to look at what each of the components are in our specific example. So our 8x plus 30, that's our f of x. And what the limit is equal to, that's your L. And the value that the x is approaching, that is a. So when we start with the blue highlighted, we have the absolute value of f of x is 8x plus 30 minus, from the blue highlighted part, our L is a -2. So we're going to have minus a -2. Close our absolute value and have that less than, and we're going to write the notation for epsilon. Now simplifying what's inside the absolute value, we have the absolute value of 8x, and then 30 minus a -2 is 30 plus 2, or plus 32, is less than epsilon. And now we can rewrite our absolute value of that expression as less than epsilon as a double inequality. Negative epsilon is less than 8x plus 32, which in turn is less than epsilon. So that allows us to write it without an absolute value and actually work a little bit more to transition this double inequality. Now our goal is to get x alone in the middle first, and then be able to work towards what our yellow highlighted part is. So to get the x in the middle, we're going to subtract 32 from all three parts. So we'll have epsilon, our negative epsilon, and then minus 32 is less than 8x plus 32 minus 32 less than epsilon minus 32. So again, we're focusing on getting x alone in the middle. Simplifying this, we have negative epsilon minus 32 is less than 8x, which is less than epsilon minus 32. Now I still need to remove that coefficient of 8, so we're going to divide all three parts by 8. And when we divide all three parts by 8, with each of the left side and the right side, we want to think of this as a negative epsilon over 8. And then for this left side, negative 32 divided by 8 is a -4, is less than x, which is less than epsilon over 8 minus 4. Okay, so our x is in the middle. Now look at what's highlighted in yellow. What we want in the middle is x minus a. Recall, our a is what the x is approaching. So we want to subtract a negative 4 from all three parts. So we have a negative epsilon over 8 minus 4, and then minus that negative 4 is less than x minus that negative 4, which in turn is less than epsilon over 8 minus 4, and again minus that negative 4. Now simplifying all of this, we have negative epsilon over 8 on the left because the minus 4 and the plus 4 will remove. I have an x plus 4 in the middle, and I have an epsilon over 8 on the right. So this gives me negative epsilon over 8 is less than x plus 4, which is less than epsilon over 8. That has that balance between the left side and the right side just being opposites of each other. So I can write that as the absolute value of x plus 4 is less than epsilon over 8. And that transitions to what we have in that yellow highlighted part. So our delta is equal to this epsilon over 8. Now when we want to actually show this as why that works to prove our limit, and I'm going to do this over on the left in this open space. So this proves that limit, it works. Delta equaling epsilon over 8 works since start with your first line of what we began with on that right hand side. We have with what we began with on that left hand side, the absolute value of 8x plus 30 minus a negative 2. Well, that's equal to the absolute value of 8x plus 32. And here a common factor of 8 can be factored out of the absolute value. So that's the absolute 8 times the absolute value of x plus 4. But the absolute value of x plus 4 is less than epsilon over 8 because it's less than delta, and delta is epsilon over 8. So I have 8 that is less than eight times epsilon over 8, which is less than epsilon. And we get our original f of x minus L is less than epsilon when we have our delta to be chosen to be that epsilon over 8.